Please start. We are live now.
Good afternoon, everyone. Welcome to the Jigyasa Adult Tinkering Lab webinar series. CSIR has signed a letter of intent with Atal Innovation Mission on 5th of June 2020. The aim is to establish connectivity between CSIR Jigyasa program and Adult Tinkering Lab. As part of the Jigyasa Tinkering Lab, a webinar series was launched which had 15 webinars during June 15 to 22nd of September 2020. The focus of the webinar was to overcome the myths in public, especially students, on COVID-19. With the help of this initiative, large number of students were provided with an opportunity to directly interact with the scientists and inculcate a culture of curiosity by asking questions. With a massive reach through social media platforms, the webinar series has been once again restarted and is positioned as Demystify Science Series to be the part of CSIR's and Niti Aayog's Azadi Ka Amrit Mahotsav initiative. As the name suggests, the webinar series is expected to demystify various myths and provide a scientific perspective to children, enabling them to understand nature better and become a responsible citizen. The first talk in this web series was by Dr. Shekhar C. Mande, former DG CSIR on Molecules to Life. Second was by Dr. Anil Bharadwaj, Director, Physical Research Laboratory on the topic Indian Planetary Mission. And third by Dr. Chintan Vaishnav, Mission Director, AIM Niti Aayog on the topic Demystifying Innovation. The fourth presentation was by Dr. Milswamy Annamalai on the topic Science to Learn or to the Change. Today, under the Demystifying series webinar, we will have our fifth popular talk delivered by Dr. Mukesh Jewariya, Senior Scientist from CSIR NPL New Delhi, on the topic Realization of SI Unit Meter, History of Measurement of Length. Dr. Mukesh Jewariya received MSc in Physics in 2003 from Indian Institute of Technology, Roorkee, and MTech in Laser Technology in 2006 from Devi Ahilya Vishwavidyalaya, Indore. He received his DSc in Physics from Kyoto University in 2010. From 2010 to 11, he worked as a specially appointed researcher in Renovation Center of Instruments for Science, Education and Technology, Osaka University. Later, from 2011 to 12, he worked as an assistant professor in the Institute of Technology and Science, the University of Tokushima, Japan. He was a visiting scientist from 2015 to 17 at Korea Atomic Energy Research Institute, Daejeon, South Korea. Currently, he is working as a senior scientist at CSIR National Physical Laboratory, New Delhi from 2012. He is a recipient of Mombo Kagasho Fellowship, Japan, JSPS Kaknehi, Korean Research Fellowship, etc. Apart from these achievements, he has also qualified GATE, CSIR NET, and JEST. With 153 publications, 2 book chapters, and more than 60 conference papers, he is a lifetime member of Indian Physics Association, Indian Laser Association, Optical Society, Korean Physics Society, etc. He is in the editorial board of Optical Materials, Optical Communications, and other journals. He has also been a reviewer of many journals, including PRL, PRB, IEE, Optical Letters, Materials Express, etc. His research interest includes generation of high-power terahertz pulse, terahertz spectroscopy, terahertz imaging, terahertz frequency, meteorology, length meteorology, dimensional metrology, development of materials for terahertz detectors, and ultra-fast spectroscopy. His current interest is to realize SI unit meter using quantum standards optical frequency comb. Today's talk is on the topic Realization of SI unit meter, history of measurement of length. And Dr. Jewariya will talk about the past, present, and future of length and dimensional measurements, covering the evolution of SI unit of length through its various definitions from the ages, from cubic system to optical frequency comb. The comparison of dimensions of historical monument with informal and official units establishes the continuity of words measurement system. We present the introduction of metric system and its progress through the ages in this talk. Dr. Mukesh, over to you, sir.
Thank you, ma'am. Thank you very much for such a nice introduction. I am really feel very pleased to have such a nice introduction by you. And I will definitely uh, tell today that what are the basic requirement, what are the basic requirement of the human needs that will lead to the change in the redefinition of systems of measurement. So before that, let me first share my uh, PPT. So just tell me whether they are visible. Are you able to see my screen?
Yes,
Can
sir, it
anybody
is
tell me?
visible.
Yeah. So today I will tell you about the realization of SI unit meter, the measurement of the length. So from the history of ages, from the period of the pyramids of Giza in the Egypt to till today, the latest definition based on optical frequency comb. So let me talk to the realization of SI unit meter. So it is the measurement that makes science scientific. So whatever discoveries, whatever phenomena, whatever science we are presenting, if we cannot do the measurement in terms of some number, measurement in some terms of a curve or graph, measurement in terms of data, so it's the measurement that makes the science scientific. Without measurement, we cannot say, because how can you say that you achieve a pressure of, let's say, 10 to the minus 7 Pascal bar, atmospheric bar? How can you say that I reach at a temperature of, let's say, 10 Kelvin? How can I say that I reach at a zero temperature? So that means you need a number to define. Okay, wherever you will feel that you are not understanding, you want to ask some question, you can ask. So I want to really make this subject as lucid that a common layman can understand. So it is the measurement that makes the science scientific. So as we know, the measurements will based on 7 SI unit. We call 7 base SI unit that fix your measurement in all the daily life. So suppose you go to measure a vegetable, let's say 1 kilogram. So you need a unit to measure that weight, and that is 1 kilogram. If you want to buy a cloth, suppose you want to buy a cloth of 1 meter, then you need a unit for length, how much it is, let's say 2 meter, 3 meter, 4 meter. So you go to the office and you say, I have to reach exactly at 3 p.m. for a meeting. Then how can you say you need a unit, you need a quantity, you need a physical parameter to define that time, that is second. When in your home the electricity comes in current, so to measure current you need a unit, that is ampere. You say something, oh it's very hot, today's temperature is 40 degree, so to measure temperature you need a unit. What kind of unit, what kind of measurement system we have? So we call it Kelvin. So that Kelvin define how hot and how cold it is irrespective of some unit. So you do the chemical reaction, you take 1 mole, 2 mole, 3 mole, that amount of substance. So that unit to define that amount of substance is mole. Every day in my room I study, okay, and there is a luminosity of that tube light, that bulb, that luminosity, how it is defined, that defined by candela. So this is the international system of units, because all the units, directly or indirectly, they depends on these 7 base SI units. These are known as SI units, and based on these there are some other derived unit, like for speed, for uh, force, for other things, because but they are anyhow directly depend on these 7 base SI units. So today in my talk I will discuss about meter, how that measurement system evolved when people don't know what to measure, how to measure. Okay, so suppose I made a house and I cut a wood, okay, how long it is, nobody knows that time. So you know how counting is started, people don't know counting like 1 2 3 4 5 6 7. But then they, what they found, that they they are basically the cowboys, shepherds, okay. So what they do, when one sheep or goat go inside the yard, they put a stone, then another stone, then another stone, but they don't know the number is 2 3 500, but they have 100 stones. So based on that stone they count. So previously also there was no measurement system. Then people thought to make a measurement system. Okay, so what is measurement? How can I say, okay, this road is 200 kilometer, let's say Kanpur is 200 kilometer, Jaipur is 250 kilometer, Chandigarh is 230 kilometer, moon is one around let's say 1 lakh kilometer, and Mars is some light years. How can we say? Because how can we measure? Okay, so measurement is a qualitative comparison, means you compare some unknown to a standard. So how can I say this is 2 meter? Because it is exactly 2 times of a meter which I am having. So I make a standard, I make a some kind of road artifact which is of 1 meter, which is of 1 meter. Based on this meter I can say this is 2 meter, this is 500 meter, this is 500 meter, this is 500 centimeter, or this is 1 micron. So we are doing a comparison, a qualitative comparison of an unknown quantity with a standard quantity. So what we do, we have to choose our standard very wisely, more wisely, means to whom we make the standard, because that standard defines your measurement, and that measurement will lead, that measurement is the growth engine of your research, growth engine of your economy, growth engine of the country. The better the standard artifact, better the standard choose, will lead to the growth of the country, growth of the humanity, growth of the society. So the question behind this redefinition is how wisely we choose the standard so that our economy, our societal structure, humanity should grow more fast. Okay, so to have this international system of units, there is a organization that is in France, BIPM, Bureau of Weights and Measure, International Bureau of Weights and Measure. That is the custodian of all the 7 base SI unit. But this institution is run or governed by a committee. That committee is known as CIPM. And the agenda of CIPM, they do the conferences and check time to time that which definition, what definition need to be changed according to the need of human, need of society, need of our daily routine work. So based on the feedback and other things, if you have heard on 19 May 2020, all the definition have redefined based on quantum standard. So previously, as I told you, if I want to measure a kilogram, I have some artifact that is of 1 kilogram kept at BIPM. If I want to measure a meter, there was a rod that is of 1 meter that was also kept in BIPM, and every country given the replica of those artifacts. Similarly, for time, current, mole, other things. So there is a system of international. But on 19 May 2020, this artifact-based system is changed from artifact to fundamental constant. So now kilogram is defined by Planck constant H. You know, maybe you have read in your 11th and 12th book. Then meter is defined by the speed of light, that is also a constant. Time is defined by the transition frequency of cesium atom. Current is defined by electronic charge. Kelvin is defined by Boltzmann constant, and mole is defined by Avogadro number, and candela is defined by candela luminosity. So this is now new definition, and these are adopted on 20th May 2020, that all the base SI unit now depends only and define only on fundamental constant. So there should not be no ambiguity, no change, no difference from country to country, people to people, time to time. So all the base SI unit of the international system of units will be defined by fixing the values of fundamental constant of nature. So you know, 20th May 2019 is that 20th May is World Meteorology Day, will experience the greatest revolution in the measurement since after French Revolution. So French Revolution, which was also a kind of revolutionary thing which changed not only the France but the whole world. So similar way, 20 May 2019 it was a revolutionary day which changed all the measurement systems of this world, this universe. So to understand how this is possible, I will attempt to bring you a short history of length, because I cannot tell the full history because there are many other things. But I will give you a brief idea how measurement was started. And I will take the example of length, because length is already defined by a constant of nature, and I am working in the department of the length. I am working in a section where length for the unit of length meter is realized. So I will give the example of length, how length is changes. So you know, in the ancient time when there was no measurement system, how people define the length. Nowadays everybody are comfortable in English. If somebody not comfortable, I can use both the language. So in old age, or in the initial days of the humankind, you say, when there was no measurement system, people use body parts like hand, foot, palm, forefinger. अभी हम कहते हैं 4 अंगुल, एक बिलान, heart, yard, phantom, kind of things. So people used to take the length of the body of human as a standard. So thus this early approach to use length used by the human body as a standard was established. People take some person or use the length like this. But you know, there is a problem. There is a problem that this was not consistent, and this was convenient but not consistent. A tall fabric merchant will be selling you a large amount of cloth, but a short fabric merchant will sell you the short. So nobody will go to buy the cloth from a short merchant because he will give the less quantity. But as per your system, he is also selling the same amount of cloth by his body parts. So body of a person changes. Body of this standard, you can say length measurement changes from person to person because body of a person is changed. Even four brothers are not same. Okay, four men are not same. They have some little difference in their body parts. Okay, so this is very inconvenient. This is very inconsistent that whose body we should follow to measure certain. In old age, if you remember, let's measure this land. So they go by their foot that how many steps you have walked. Okay, as per the steps of walk, they measure, okay, this is 1 biga, this is 2 biga, kind of things. To solve this problem, they thought, okay, we will not go for the body parts of a particular person, but the one solution is to use a particular body. Then who was the most powerful that time? The powerful person is a king, Pharaoh. Pharaoh means the king of ancient Egypt. Okay, so they, why not we use the body of a king as a standard? Okay, so they use body of king as a standard, but so they take the body parts measurement like farm and cubit. So cubit was one of the first official definition of measurement of length, but till that time there was no concept of meter. Okay, they called it cubit. Cubit defines from middle finger to the bottom of your elbow, and this they called cubit. So in this way, from a body part of human, they came to the body part of the king. And you see, using these standard, because that time they don't know that is meter or half meter or whatever it is, whatever the measurement from elbow to middle finger, this length they called it cubit. And surprisingly, you see that measurement system was modern system. Based on this system, based on this royal cubit, they made the pyramid of Giza, so nicely constructed. So metrology measurement system was there, though they don't have official name, they don't have official terminology, but they have an official record that we have some measurement system, and that system is cubit. Okay, so Royal Egyptian cubit, based on the size of the pharaoh's forearm and hand, was embodied as an artifact. Artifact means it depends on some material object. Okay, so primary cubit they made is of granite, and then secondary cubit is, because primary you cannot use everywhere. Okay, it may break, it may collapse, it may fall down, it may get damaged. So they made the secondary cubit in the wood, form of wood. Okay, and I will tell you this is not convenient later then. So every month they recalibrate, because wood at the time of, let's say, winter or rainy may swallow, become kind of things. In winter it become hard. So every month they recalibrate based on their royal cubit made of marble or granite. And that time there was a death penalty for non-compliance, because every infrastructure, every building they make depends on this royal cubit. So now you think one big problem, of course, primary cubit is made of granite, second is made of wood. But there is also problem, because these are not considered, you cannot keep for long time. But other is, suppose a pharaoh, means king of India, want to sell something, then the dimension of king of India is different the dimension of king of Egypt. Then emperor of let's say Saudi Arab, then emperor of the Brunei, emperor king of England and America, all have different body. Now the standard used in America cannot be used in India. The standard used in India cannot be used in UK, if this is the standard, because it's not for all the people and all the time. Okay, so they have their own standard, and it varies from cities to cities, town to town, because everywhere there is a king. So similar artifact sometimes varying from town to time, where common standards for length measurement in Europe, especially in Europe, they are different for even for a small town. So how to make a universal, how to make a universal system, okay, and how we define the length that is universally accepted. So at the time of Industrial Revolution and French Revolution, people thought, because that time the trade, commerce are so popular that people want to sell the things made from one place to another place, but there was no common measurement system. When there was no common measurement system, you cannot easily sell, you cannot easily trade among two countries, two people, two cities, because one measurement is different from the other measurements. So during that one, the king of France, he made a committee and called the intellectual of those time, let's make. So meter was the first definition, and people call the meter convention. So meter was the first definition that was decided, and after meter, kilogram was decided. So meter was among those first definition which are established by the people to make the universal measurement system. So in 1719, when intellectuals from different parts of Europe, they gathered, they thought, what is the best thing which will not change over the time? And they thought, did the brainstorming, make many kind of meetings, everybody have their different views, and the collectively they came on a conclusion that earth is constant, the diameter and radius of the earth, curvature of the earth is constant. So we have to make a measurement system which is constant for all the people, for all the time. So they took a big rope. That rope is around 1 kilometer of 2 days. Okay, and they measure the curvature of the earth from, you see, North Pole to the Paris, half of this distance. Okay, they measure from here to here, here to here. It took many years. It took many years, and they started from North Pole to this one and measure the curvature of earth. Okay, and then they found that 10,000 kilometers, 10,000 steps of that rope makes the curvature of the earth. But that 1 kilometer is very large. To conserve, to preserve that rope, that length is very, very difficult, because 1 kilometer is too big. So what they took the 1,000 part of it and made it and give the name of a meter. And in this way, meter term was given to this scientific society to the people, to the universe. So people adopted meter as a primary unit to measure length. So meter was to be the measure of all the things and was in the spirit of equality and fraternity to be available for everyone at that time, since that meter was constant. So meter is one part of 10 to the power 6 of the distance from the equator to the pole along a meridian passing through Paris. Paris is used they because King of France given this idea. So Paris they describe as a 0 point. So then this definition came from all the time, from all the people. All people at all the time have same meter. Meter is not going to change from year or people to people. So based on this 1 meter, the part they made like from 1971 to you see 1979 they made a platinum bar. You see this is the platinum bar. So the earth as a definition of meter was clear for everybody that time and was more stable and global than the Perot's forearm or a city specific standard, but it was hardly more convenient. That is also not convenient. So the meridian definition of meter was used to create an artifact and standard from this point to this point. This is known as 1 meter. And so this is known as meter bar. So this was very much in the spirit of Egyptian cubit, where the definition of length was a primary standard artifact. Similarly, we made an artifact. But now artifact is not marble and wood, but artifact is a platinum bar. Why people did the research, people did many kind of other things and found which one is the hardest material at that time, which can be used to make that meter bar. But till you saw from 1799, this platinum bar is used, but in 1875, almost after 100 years, you can say, Tessa, a mechanical engineer, he came to a conclusion that if we use this meter bar, because this platinum get corrosive, easily can break as compared to other things. So they put the alloy, platinum, iridium, okay? And they gave a new design also. You see this hexagon kind of design. Here there is no design. If this will fall, this will give some scratch, give some bend. But this meter bar, you see here, have kind of 4 faces. And he give the mark here, and the distance between these two marks is 1 meter. That is same as that platinum bar. But now this meter bar is made of platinum and iridium. And this is known as the first international prototype of the meter. And India received the number 57 copy, and we are the 57 nation to join that in year 1957. So we have given the copy number 57 as the same replica of this meter, and then BIPM said to all the country that you keep this meter bar as your archive, as your artifact, and make the measurement of any kind of desire from micron to, let's say, light year based on this 1 meter in your country. So following the famous 1870 convention de meter, that was the first meeting, we call it a meter convention, but in French they say convention de meter. The meter of the arches was replaced with a line standard. Now this is a line standard, and it is known as the first international prototype of the meter. So the meter, what is meter? We measure the distance using a standard length. That is meter. Of course, 1 meter. So historically, that was a kind of artifact rod made of platinum. And historically, this standard depends on the size. So that is the fraction of Earth's size. Okay, that was the fraction of some Earth size. So Earth people believe that Earth dimension, Earth curvature, Earth size will not change. Okay, so this meter based on the distance from North Pole to equator. So now a meter becomes the SI unit of length. Okay, but nowadays I told you the SI unit is changed because this is artifact. Okay, this have some limitation, this have corrosion. Over the time it will change because it's a metal. Okay, there kind of chance of damage. If somehow your meter is damaged, है ना, and you are not at par to the universal measurement system, then what to do? Then people thought of some other fundamental constants, how to define particular quantity which will not change even over the time. So later I will tell in my slides how that is changed. So the speed of light, they define how, what is the speed of light. So they define the length in terms of the speed of light, and I, in my next slide, I will show you why. So soon after meter bar, means people told, complain that this meter bar is not good, how to define micron level, because that time precision measurements were done by Michelson interferometer, by Michelson and his team, and then there was a atomic structure comes in the picture. So how to define the nanometer angstrom that time? But world was busy in making the roads, making the buildings, है ना, going on ocean voyage, going from one country to another country. So nobody took care. But people, those who are pioneer, they started working. Okay, and soon after this meter work, they found that the distance between two scratches on the meter bar become inadequate as a standard, and people use the wavelength of light as a de facto standard. So I will go back in my slide. So in practice, what people want to use, they want to use a particular wavelength or frequency, but frequency is the better choice. You know, in your textbook, you may read that only there is one quantity which cannot change when it passes through the medium to medium. Wavelength is changed, refractive index is changed, all other parameters change, but frequency will not change. So if we fix the frequency and measure the wavelength corresponding to that frequency and use as a source to measure the 1 meter. So they use light as a source de facto standard for standard, but that time there was a monochromatic source but not the laser. Okay, so using krypton lens, maybe you have heard about krypton this one. So they use a krypton lamp in 1960, and the definition of meter was redefined. Okay, the last year the laser was invented. Laser was invented in 1960, but before that people have worked on microinterferometer, other thing. So the meter was redefined as a certain number of wavelengths of the light from a krypton lamp, and they said this must transition when happen in krypton, and those number of transition can be said as 1 meter. But soon the purity of that light from krypton was found to be insufficient for the accuracy of measurement, because the light coming from krypton is not so monochromatic, not so directional, since there are kind of fringe measurement is not accurate at that time. So from 60 to 1983, krypton was used as a primary standard of length, defined the unit length in terms of krypton transition. But meter needed to be redefined because the source krypton was not so stable. The intensity of light is not so equal on all the way, so we cannot measure the counts properly. And when we cannot measure the count of Newton's ring, we cannot calculate the exact wavelength of the light. So now we want to define the new light, and 1960 laser was invented. And the definition say the speed of light in vacuum. So 1 meter is the path traveled by light in vacuum in 1/c second. So for this, which light source we need, because light is an electromagnetic wave. We cannot take any light, like we cannot take X-ray source because this is also electromagnetic wave. We cannot take microwave because this is also electromagnetic. So we need to choose a electromagnetic wave, and that time laser was one of the most powerful electromagnetic waves. So we choose laser. Which laser we need? Then people decided to choose helium neon laser. Now, since the definition is based on the wavelength, but wavelength is changed, so we need a system whose frequency is stable. So they use iodine stabilized helium neon laser, and this was the, I will say you, brilliant choice to define the speed of light. And they defined the speed of light as 299.72 480 seconds. And then they give a brilliant, beautiful definition of meter in 17 CGPM 1983. In 1983, they gave the definition very nicely, that the meter is the length of the path traveled by light in vacuum during a time interval of 1/c 299.792 480 seconds. In this particular fraction of time, whatever path is traveled by light is known as 1 meter. And I will tell you, historically, this path is same as the meter bar we have, the prototype of meter bar we have. So that was very nearly exact. I say the word nearly exact. It's not exact, but nearly exact, the same as of that artifact. So this effectively defines the speed of light given by lambda f is equal to c. So if you know particular frequency, you can get to know the wavelength. So iodine stabilized helium neon laser, that is 633 nanometer, 474 terahertz, is the primary standard of length. And as I tell you that it depends on the measurement of frequency. So if we know the frequency of any light, we know its wavelength lambda. So this definition incorporates improvement in lasers and frequency measurement. So measuring frequency accurately required the correct definition of meter. So you see, as a de facto, people choose iodine stabilized helium neon laser, and as definition changed in 1983, and laser started to develop from 1960. Krypton lamp became the official definition of meter in 1960, but from 1970, almost everyone was using an iodine stabilized helium neon laser as an unofficial standard of length, and such length were not in SI meter. And later, when it became official definition, people use helium iodine stabilized helium neon laser like this to realize the SI unit meter. And on similar way, we in India have this iodine stabilized helium neon laser. So this helium neon laser directly and indirectly gives all the measurement, all the infrastructure of India. This is the mother, this iodine stabilized helium neon laser is the mother of all the measurements in India. Directly and indirectly, whatever you measure from needle, tip of the needle to this aeroplane, to the ship or the biggest structure, that directly and indirectly depends on this high iodine stabilized helium neon laser. Then we use the secondary source and make an interferometer using this another laser. So we compare the wavelength, or not only wavelength but frequency, you can say the frequency of this laser with this laser. So primary frequency to define the SI unit meter was 474 terahertz, that is 633 nanometer, and they will be compared, that is known as calibration. We calibrate this frequency with this frequency. So in 2005, as I said, you see here, if you see, the definition of meter incorporates the improvement of lasers and frequency measurement. Since iodine stabilized helium neon laser have 5 frequency components. So to log, you have to log the frequency component. So there are many components like A, B, C, D, E, F, G, H, I, J. But prominent component are D, E, and F. So you have to log the iodine frequency on this component, any one of this component, and measure it correctly by taking the time signal. But there is uncertainty because you depends on these 5 and 6 frequency component. So there is an uncertainty of the measurement of the frequency. So to solve this problem in 2005, of course, Theodore Horns and John Hall get a Nobel Prize. So in 2005, Nobel to John Hall and Theodore Horns was for dramatic improvement in the measurement of frequency. And they came with a new idea. The new idea gives more beautiful definition of the meter, and that is beautiful and brilliant. So today, means on 20th May, the CGPM is about to bring the same beautiful kilogram, but they bring the same beauty in terms of optical frequency comb. So now most of the NMI means the institute like NPL in other countries, those who are custodian of SI unit use optical frequency comb. So as I said, optical frequency comb is more accurate as compared to iodine stabilized helium neon laser, because in helium neon laser you have 5 components. So locking of one component have some uncertainty, but in comb we have 10 to the power 5 to 10 to the power 6 spectrum. They are equidistant. In iodine stabilized they are not equidistant, but in comb they are equidistant. So let's say I will give this example. If you have 5 people and you want to call A, B, C, D, E, and suppose there are nobody is present, and suppose there are 2 or 3 present, then you depends on these 5 to do that work. But if I have 1 lakh employee of same caliber, of same intensity, of same equidistant or equal, I can choose anybody and do my work. So my uncertainty of choosing particular frequency is less as compared to iodine stabilized helium neon laser. So comb is chosen as a choice to be better, more accurate than iodine stabilized helium neon laser. So what is a comb? A comb is an optical ruler consisting of equidistant optical frequency in one wave, this wavelength, that was on 10 to the power 5 to 10 to the power 6. So I can choose one of the frequency, and my, you see, my uncertainty of measuring is in 10 to the power minus 15, and in iodine stabilization is 10 to the power minus 7. It means if I go 10 to the power 7 meter, let's say 10,000 kilometer, there is a uncertainty to measure my distance. Okay, there is a change in this total distance about 1 meter. There is a error of 1 meter when I go up to 10 to the power 7 meter. But with comb, if I go up to 10 to the power 15 meter, more than the distance of moon or Mars, there is change of 1 meter. So accuracy improves because your selection locking of frequency have many components. So what you take the signal for time from CGM atomic clock, use optical comb to realize the SI unit meter and measure the optical frequency, because this is by CIPM recommended, and by this you can measure the wavelength and make the interferometric method, and by this interferometric method you can transfer the uncertainty to lower systems like gauge block, distance meter. So your accuracy, whole hour accuracy increases. Why optical frequency comb? Because it is a direct realization, because you don't need to depend on a particular frequency to be logged, and it's a real-time synchronization with the time. So optical frequency comb is a better choice because you have n number of modes and you can log any mode M0. So M0, M+1, M+2 have equidistance. So the best thing is why? Because locking iodine stabilization depends on refractive index of air, but here it don't depends. It's independent of air pressure. So your locking of frequency is much better as compared to iodine stabilized helium neon laser. Okay, this is particular experiment setup, and this is the optical frequency comb we are going to buy soon and realize SI unit meter using this optical frequency comb. With this my word, I say thanks, and I'm finished my talk here. I hope you understand how from human body to a very sophisticated quantum standard we came with traveling long journey of, let's say, more than 200 years. Thank you.
Thank you, sir. It was indeed an insightful presentation which highlighted evolution of measurements starting from the ancient time till using quantum standards and its usage in our day-to-day life. So we have few questions. A question from my side also. I was wanting to know that whenever we are selecting elements for any type of measurement unit, so how do we, what is the criteria for that selection? How do we select any element as per se for the measurement unit?
Okay, that depends on the human need. Okay, need of that particular time of the society and available technique. Okay, so like in 90s, 80s, the better choice to choose a laser, and then handy and other things is helium neon laser. But nowadays there are many other methods people use, but optical frequency comb is more stable and more precise. So based on the requirement at that time, changes at particular period, and what are the best available technique. Okay, then we judiciously and wisely select which one have to be adapt. So this, as I said, CIPM, they take care of all the measurements taking place at that particular time. Okay, and then make a conclusion which one is the best adaptable, user friendly, easy to use kind of things. So these are the basic criteria. Now why we need
So
why need such a, why need we such a high ultra precision? Because if you go to make a road, 1 meter is less, no meaning. But when you go to a space voyage, So Chandrayaan is stopped 2 kilometers before. Why? Because we don't have that much precise source for the simulation calculation. Okay, now you measure the picometer. If your realization of 1 meter is not accurate up to that level, you cannot measure picometer. And now you see nanometer and picometer devices are there everywhere in our electronics, other thing. So for not for common day, but for very high precisely application, you need judiciously to measure. You need accurately, precisely to measure your measurement system.
Okay, sir. So another question was asked by a student that what is the instrument that can measure heavy weights?
Heavy weights. Okay,
Yes, sir.
in mass they have many balances. Okay, robotic arm kind of things also they have. So depending on how much weight you want to measure. Okay,
Okay.
so there are many other
Okay.
instruments, but how much is like 500 kilogram they are able to measure, I think. Above than this, I don't know.
Okay, sir. So these were the questions. No further questions have been asked. And I think with this, I would like to ask all the students present online that if there is any question asked, you want to ask to sir, please go ahead. And if not, then you can always mail Dr. Mukesh and he will answer the query. And regarding this subject, particularly which was the measurement, regarding the measurements. So with this, I would like to call an end to the talk of Demystifying Science webinar. Thank you for your time. We appreciate
Thank you,
your,
ma'am.
yes, sir. We appreciate
Thank
your
you very
time,
much.
sir.
Thank you,
And
thank you.
it was a
I
very
hope to,
interesting presentation.
thank you very much.
Yes, sir. Thank you.
Thank you. So I log out. If the students are there, I have one video also on YouTube. But if nobody means, then maybe I can give the link later. People can see.
Sure, sir. Sure, sir.
Oh, thank you, thank you,
Thank you, sir.
thank you.